Welcome back. Welcome back to the course Responsible and Safe AI. Hope you're enjoying the course. What we're going to see in this part of the course is machine and graph unlearning. So this becoming a very, very important topic. You'll realize why it is important, all that in this module. But hopefully, you're also participating in the mailing list, and please do ask us any questions, join the live session, do the hands-on sessions. I think some of these modules also will start having hands-on sessions as we move. Which is a separate video that you will have where we are walking you through some code, Colab, Kaggle. All of this we will actually go through with some data sets, do some analysis, see what is going on and all of that. I highly request you to do it yourself. The reason that you want to do it also is that it will be part of the exam. It will be part of the weekly assignments. It's a required content for the class. We have also kept a content that is supplement to the course, which is there's a lot of ML basics, right? Transformers, encoder, decoder. Right. All of these content that we have recorded separately, and it is actually kept as supplement. This is for some of you who are taking the class who may not know basics that is required, is what we did. But I think if all of you can go through this, also will be nice, so that it helps you to connect things that we're talking in the course. So one is the content that the faculty are recording. One is the content that is hands-on sessions. The other is these basic content that we have put as supplement. So please try and make sure that you're up to date with all of these content. So one of the things that this slide we also saw in the week 1 content, where we were talking about AI capabilities, right? So one of the important things that is going on is this increase in these parameters, right? So if you see all over the place, 350 million to 20 billion, meaning the quality of the image has increased as we move from left to right because of the parameters that it is using to generate these images, and therefore it is also taking a lot of data to actually come up with these different set of images. Right. So the thing that is happening is pre-training set is increasing. That's this number. Which is a key component in almost all the language and vision models that foundational language and vision models that we are looking at. What is the situation now, right? The situation is most of these models are trained from publicly available data. Right? Majority of these sources are coming from internet that are publicly available. Probably when you're fine-tuning it, probably you're using some localized data or data that is particular to a company and all of that. But the foundational models are generally built across the data that is largely publicly available. Training is very expensive. We also saw this in the week 1 content. This is the same slide that I had used at that point in time. IIIT Kottayam, who's the director, it gives you an answer of Jan 2022. Interestingly, when I looked it up recently, the same question that I had asked, it actually said that as of my last update, Dr. Suresh is the director. It doesn't give you the date, but since we saw this part in the course earlier, I thought I will just use that content itself to tell you that the Jan 2022 is one of the main reason is because it's actually very expensive to do the training. Publicly available data can have information that we don't want the model to learn, or it has, if it has learned, not to use it, right? So that's also an important component, which is we don't want the a model to learn some things from the data, and if it has learned, it should not be using it. We have seen some examples before. Expensive is also here. Some values that has been made public. How much time, how much money it takes for OpenAI to train these models. What is the need, right? The need for attacking these problems or trying to understand this more is that you should be able to actually edit, remove private data, stale knowledge, copyrighted materials, toxic unsafe content, dangerous capabilities, misinformation without retaining models from scratch. That's what we should be able to do, right? We should be able to, because the models have, it takes a lot of money to train these models. Can you actually take these trained models and do some edit or remove so that we take care of these conditions that we have laid out later, which is private data, stale knowledge. Private data is my, let's take my cell numbers there, or my date of birth with other details are there, right? So that could be a private data. Stale knowledge is some old data, right? Triple IT, Quotium's director is X, which is saying, but it's actually Y, right? Stale knowledge. Copyrighted material, artists actually upload materials on the internet and on YouTube, on Spotify, all of that. So that is getting added to the model. You want to actually change. Toxic and unsafe content. Let's take Reddit is a great example, right? Where there's a lot of toxic content that gets generated, you want to remove them. Dangerous capabilities, of course, right? Bio, chemical, nuclear weapon, all of those details are there. And capabilities also, it is able to actually put them together and generate something that can be dangerous. Misinformation, fake news, information that is not true. We want to do all of this without actually retraining the model, because retraining is expensive. Some other ways of looking at the same thing, potential definition of machine learning. This is like a requirement of unlearning. Let's think of putting this slightly more formally. Can be broadly described as removing the influences of training data from a trained model. At its core, unlearning on a target model seeks to produce an unlearned model that is equivalent to, or at least behaves like, a retrained model that is trained on the same data of the target model minus the information to be unlearned. That's what the goal is going to be. So it is supposed to do everything that the original model was doing, except that the information, data that it is to be unlearned. That could be a potential definition. The exact definition of an unlearning may also depend on the downstream task or the task that is involved. For example, ML task, binary classification or language modeling, right? That could be ML tasks like, we also saw summarization earlier, right? Binary classification, language modeling, summarization, all of this. The unlearning definition could be dependent on what is the classification that we're doing, what labels do we want to forget, all that. It may also depend on the data to be unlearned, which is a set of image, news articles, knowledge of making something, right? An atom bomb, so to say. It could also depend on the algorithm that we want to use, which is heuristic fine-tuning versus deleting the model components. Right? You want to do fine-tuning or you want to delete. The goal of unlearning also, one of the big goals for unlearning is actually privacy. We'll actually see it in a few seconds of motivation for this unlearning also is coming from a legal perspective. For user privacy or harmfulness removal. It could also be because of the goal that we want. We want that the model that is trained and has the information about how to make an atom bomb or a nuclear bomb, we want it to be removed. Right? So that's what exact definition may depend on, which is MLTARS, data, algorithm, and the goal. Here is a legal connection to unlearning and why unlearning has become actually very popular. Particularly, I think we are very excited about this whole area of unlearning, but there's also a lot of excitement around how to build these models, what are the benchmarks to be built, what are the data sets that could be created, what are the better ways to actually do this unlearning is all becoming very, very exciting. Wait for the rest of the content in this module. You will also get interested and excited about it. But do look up for some of these topics. So the right to erasure. So this is the GDPR from European Union that had come, and in that one particular aspect is called right to be forgotten, which became actually very popular. So here is one or two things that we want to actually make sure that we understand to be right to be forgotten. Broadly, the idea is, look, I want to tell Facebook, I want to tell Google that, look, please delete all the information about me. Please forget about PK, right? So that's what the goal of right to be forgotten is. The data subject shall have the right to obtain from the controller. Controller is the Facebooks and Googles, the erasure of personal data concerning him or her without undue delay, and the controller shall have the obligation to erase the personal data without undue delay where one of the following grounds applies. Right. The goal is, I want to get rid of my personal information from Facebooks and Googles. The personal data are no longer necessary in relation to the purpose for which they were collected, or otherwise. These are laying down the reasons when you can actually ask for to be removed. The data subject withdraws consent on which the processing is based according to the article, blah, 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 and where there is no other legal ground for processing. So you're just saying that, look, I want to just, you gave consent for medical hospital to use the data, you gave consent for a legal firm or a law firm to use the data. You gave a consent for online booking website to use the data. Now we say that, look, I don't want to give the consent. I want the consent to be taken back, which means that they should actually delete the data that you have shared with them. The data subject objects to the processing pursuant article, and there are no overriding legitimate grounds for processing or the data subject objects to the processing pursuant over. So basically, the data subject has some problem. Data subject is us, the user of the data, the owner of the data. We have some concerns about them using the data. So it goes on, lists down many expectations of what is right to be forgotten. And the intent for me to keep this here is that a heavy focus on machine learning has come because of this expectation. So if you continue looking at this idea of right to be forgotten, where the controller has made personal data public and is obliged pursuant to paragraph 1 to erase the data, it goes on with the details. But here is 2014, right to be forgotten was thought about, is laid down, all of that. Google removed data. Google has done in the past obliged for this right to be forgotten, and the reason why we are looking at unlearning is because growth of ML and this data is being sucked. So, for example, the point that we said before, right? The data is being used for all of these models, right? So that's why the more interest from us. And removing data is hard for ML. Data deletion, or that's why data deletion or data machine unlearning has become very popular. So building on the idea for machine unlearning itself, here are two other ways to think about it. Access revocation, unlearning private and copyright data, model correction or editing, toxicity, bias, tail, dangerous. It's just putting what we have seen already into these two ideas called access revocation, which is you're removing the access to the private information, or removing the access to the copyrighted information. Removing the access here means taking it away from the model, is what unlearning here, with the aspect of access revocation. Model correction and editing, you're just editing the model, correcting the model to remove the toxic level of the models that are built. Data should be returned. Just building on this access revocation itself, Google took my browsing history and when asked it should return, this is very hard, right? That's the revocation part. Google would have consumed the data to create the model and may require proof of unlearning, hard to provide. So let's take that. If you think of Google had PK's personal data, this is Google, and PK makes a request to remove the personal data. Let's say Google says that, look, I've actually removed the personal data. How do they prove it to me? Right? That's an interesting problem, is to provide a proof for the unlearning. So, right to be forgotten, created data markets, no requirement for unlearning, hard again. So if you think about these right to be forgotten itself, the requirement for unlearning, which is the model says that you should actually just forget it. But how do I forget it? What should be forgotten? How should it, what's the cost involved? Who will bear the cost? All of that needs to be actually thought about. So here is an interesting example for unlearning itself. There are many such examples. Ram ate Lakshman's laddu. That's the data, right, which came from the internet, let's take. When asked to return, this is with Google, when asked to return, Lakshman would prefer something equivalent and not puking, right? So the idea is, look, I took the data, I consumed, I created the model. When you ask me for returning the data, I can't just sort of say, in this example at least, eaten the laddu is puking the laddu itself, but I can't just give it that way, right? Because I've used it in decision making in my models. It is very, very hard to actually return it the way you gave it to me. Or the connections and the inferences that we made with the data, that is also very, very hard to return. Right, so that's the idea for access revocation. So one of the ideas is periodic retraining has to be done so that you have the model. There's a lot of requests that may be coming. That's the next point. Requests may be coming to the ML model for deletion. right, for the deletion. Take unlearning request over a period of time, use them and unlearn the next training. Let's take this model was learned in 2022, as we saw in the slide, January earlier. And now it is July 2023, let's take. And you want to make sure that you take this, all of this into the model and delete them. Keep taking request. This is just a timeline. It could be anything the company decides. Policymakers can mandate, right, periodic retraining and set economical viable deadlines to offload the cost to the model owners. I mean, we saw 100 million it takes to train, which means do we expect OpenAI to do this every month? Very hard, right? So what can the model owners do? What should the model owners do? What should the government think about it? What policies should be laid down? All that is a super interesting question to think about. Now let's get into model correction and editing, right? So here, again, all of this is treated as a post-training risk mitigation mechanism, right? Which is a model is built, and then at the end of the model getting generated, you want to actually make changes to the model. That's what model editing and correction can do. This is more of a desire than the necessity, right? You want to make sure that these models are desirable, usable. We don't need formal guarantees or proofs for usefulness, even though the formal guarantees and proofs are very hard. Scientifically safe models are, sufficiently safe models are deployed, like the chatbots, right? Like the chatbots that we saw, even though there are problems, but the intent is that, look, the chatbots is deployed, it has the information from the open source data, it has built something. So later we'll actually look at this benchmark. So these are benchmarks that are getting popular in terms of how these model editing, model corrections can be done, and publicly available data set, how you can do some experiments around it to show how well your unlearning method has worked. Okay, hope that helps. Basically what we did was we started looking at what the current situation for the ML models are, some motivation for what unlearning is, why unlearning needs to be done. Right. Now let's look at forms of unlearning. Now that we've understood that unlearning is necessary and unlearning needs to be done given these models are, there's something called as exact unlearning, approximate unlearning, just ask for unlearning. Some of them are self-explanatory, but let's go through one by one as we see it. Exact unlearning, approximate unlearning also can be broken down into unlearning via differential privacy. We'll actually see what this is. As part of the course, you will also look at differential privacy as a important component for keeping the models safe. So we'll have some content around differential privacy also. Empirical unlearning, where data to be unlearned are precisely known. You know that you want to remove PK's PII. That's one way of thinking about it. Whereas empirical unlearning, where data to be unlearned are underspecified. You don't even know, or you were kind of vague on what needs to be removed. You will see examples later, so you'll understand the difference is this one is for DP, this one is for exact data, you know, this one is for I don't know what exactly to remove. I know that I have to remove the knowledge, but I don't know what all that means exactly. That's why it's also called approximate unlearning. Okay, so here is one method for exact unlearning. So this, let's look at the diagram. So here it is the original training data, T, and this is broken down into, which is called as sharding, the idea here, right? Which is take the larger model, break them into smaller models, right? So that's what is happening here. Larger data, break them into smaller data, create a smaller model, and then aggregate the model. So the whole SISA training is actually called as sharded, isolated, sliced, and aggregated. Sharded, right? And then isolated, sliced, and aggregated. Aggregated is here. Here it is sliced also. Data is sliced. And isolated is that the idea of what you want to unlearn, which is D, is actually kept here. Right? It's in one of the sharded data. Right? Okay, so this is STH is a constituent model. DS is the Sth data split. So this is D1 here. This is DS here, right? And then R slice of Sth data, that is DSR, which is D2 comma R is what it is. 2 comma R is rth slice of the second data split. That's the second data split. And then the red one is data to be unlearned. All components are understood. Data, sharded data, data to be unlearned, model that we are building only from the sharded data, and then model is aggregated, final output is here. So SISA training, data is divided into shards. Just going through the same thing as I just explained. Data is divided in shards, which are themselves divided in slices, right? Shards, this is the shard, slices. One constituent model is trained on each of the shard by presenting it with incremental many slices and saving its parameters before the training set is augmented with a new slice. When data needs to be unlearned, only one of the constituent models whose shards contains the point to be unlearned needs to be retrained. Retraining can start from the last parameter values saved before, including the slice containing the data point to be unlearned. So the idea is that, look, if I were to do unlearning, if I were to actually remove this, only this model needs to be retrained rather than the whole model. Right. Again, please understand this is exact unlearning, so you exactly know what to be removed. This model takes, let's take $100 million to train. This, if you just break it down to S to B, let's take 100 or 1,000 or something. So it will be that much lesser cost. Okay. For example, if you just do 100, it will probably be 1 million each. If you do 1,000 shards, it'll probably be $100,000, which is probably cheaper than putting $100 million. Right. Okay, unlearning model and retrain model to be distributionally identical. So it's important to keep this identical in mind, which is unlearned model and the retrained model should be distributionally identical. What I have unlearned and what I have retrained should be distributionally identical. Unlearning involves retraining the model corresponding to and without the data points to be unlearned. Right? You want to, that's what we did here. We already saw what this is. So that's the idea for exact unlearning. What are the benefits of exact unlearning, right? Unlearning, the proof is actually by design itself, because SISA by design, unlearned data never contributes to the other components. So if you see here, this D 2, 2,3 or 2,2 never contributes to this model, or any of these models in between. And therefore, it's not going to affect the model. It's not going to affect the retrained model. Interpretability is by design. We understand how certain data points contribute to the performance because it's a smaller model. The D that you want to remove, we understand how it must have affected the performance of the model itself.